We wake up in the morning to do what we need to do. We prepare and then head out to wherever we need to go. It feels as if we're in, I would say, the normal daily routine. We don't question it, neither do we question the wider world. Because although no one can know everything, we humans like to believe we do. But today, I want to deviate from this human tendency and talk about things that I don't know, that we don't know. Have you wondered how little we know, not just about the center of the earth or the wider universe or the human body, but also about ourselves? When we hear about the latest scientific discoveries, we get the impression we're on the verge of deciphering the mysteries of humankind and conquering the universe, but it's not really true. I flip the pages of a science magazine and I read about all the discoveries and creations that seem more like science fiction than actual reality. Like, for one, nanotechnology is booming. No later than tomorrow, nanobots capable of monitoring our health and protecting us from disease will be swarming inside our bodies. They'll even transmit information about our health status to a globe-spanning wireless cloud. It's impressive, isn't it? Especially when considering how scientists don't fully understand our own bodies in the first place. Like, how do cells know how to be human? How does a spherical bag of proteins form legs, heart, and the brain? We have no clue. Scientists used to believe it was the proteins that carried the information, but now we know they're just the building blocks. They're useless without a blueprint and a mason. Today we know it's the DNA that carries the instructions, but we're still today not exactly sure how the code is read. The underlying mechanisms for how can a stem cell become any cell type in the body still eludes human understanding. Although we know that activation of certain genes is responsible for cell differentiation, there are many gaping holes in our comprehension of this process. Cells are known for their extraordinarily complex compositions, but asking how do cells form from a code coming from a mere chain of nitrogen bases, phosphates, and sugars gives 1 million more questions. In 2001, the Human Genome Project was announced fully complete, but in truth, it was never fully complete. 9% of our genome remained unsequenced, with 341 gaps reported. Most of these were located in the centers and the ends of our chromosomes, called centromeres and telomeres. These are responsible for gene replication and DNA protection. But they have also been linked to certain diseases and aging. Understanding aging and the diseases of the aged, like cancer, may be greatly assisted if we can look in the right places, but we cannot study these unknown sequences in detail without discovering them. The technology we have today is still not capable of doing that. We often heard news about the world's first fully artificial cell, a cell whose genome and structure are completely synthetic and whose parent is a computer. The Craig Venter Institute announced it had just done so. A cell boasting a genome entirely fabricated by machine and whose components all come from that genome. But the cell still had to come from a pre-existing cell. But building a fully, truly artificial cell remains a matter of our future. We only have a general understanding about how life evolved on Earth. But we can say for sure that evolution is much smarter than we are. It is creative and inventive, beyond the scope of human imagination. That's something researchers who fight against infections have to relearn again and again. It took only 35 years for mutations for harmless bacteria to become flesh-eating, impregnable, and lethal. When we hear about new antibiotics, we're confident in newly discovered ones, But the truth is all of our antibiotics have been built upon existing ones discovered by 1984. What I find rather quite alarming is that our latest strain of antibiotics used against powerful gram-negative bacteria infecting patients has been discovered in, you won't guess, 1962. It's 2020. We can land people on the moon, but we still lose the germs. More than 85% of all life on Earth is unidentified. According to a study that postulates our planet is home to about 8.7 million species, but current extinction rates could mean that many of these will become extinct before we even know what they look like. We don't even know what's even in the vicinity of our own homes. Take the garden snail, for instance. Its compelling tales of survival are ignored. We don't see its struggles to find food, shelter, avoid predators, find a partner, locate a site for future eggs. The snail is a survivor, a tiny one, a slow one, but it is an animal part of a great dynasty of mollusks, evolutionary oddities that have survived and thrived for over 550 million years. And today, number potentially 50,000 to 200,000 species. A snail is an icon, a treasure, and a relic. So the more we know how much we don't know. We enter a new age of climate change, resource depletion, robotics, nanotech, space colonization, unprecedented migration. And we have yet to see all else that we will counter in the rest of our lifetimes. It's a teeny, tiny dot of what we know versus what's out there. And even though we often believe we always have to look to the distant galaxy or the ocean abyss to be at tomorrow's farthest frontiers, the very truth is, these are within each and every one of us. Unseen treasures, our very own Mars, moon, or perhaps distant earthly planets. Thank you.